I think a lot of you got to that step. Now, you need to get y by itself. So the way to get y out of here is to bring in a natural log, right? Bring in a natural log and you can kill off e, can't you? Let's just try it right now. Don't write this down. Let's just try it. If I take the natural log on the left side and take the natural log on the right side like this, I run into a major problem. The problem is this. When you take natural log of e to the y, that would be y. Yes, I agree with that. But the problem is the argument of this natural log is actually two terms separated by subtraction. And so if you go back to your properties of logs, even though that's true, if you have natural log of, let's say, let's go x plus y. I don't want to use x plus y because I don't want to confuse. Let's say m plus n, right? If you have natural log of the sum of two things, this is not equal to the natural log of the first one plus the natural log of the second one. That is not a property of logs. This property, the correct way to write this property is this way. Natural log of, this has to be m times n, then it's equal to that. If you have multiplication inside of a log, you can split it into two logs with addition, yeah? But if you have addition inside of a log, you cannot split it up like this, and there actually is no way to split it up. We don't have a formula that allows you to pull that into two logs. So there's no way that I can actually split this apart and then like wipe out each of the e's. And that's like a major problem, right? So how do we get around that? Well, the bad news is that there's actually no way to proceed from here. There's no way to proceed from here. So you actually have to go back up to this line and do something completely different. Now eventually we'll need a natural log, but I want to make sure everyone understands the like inherent problem we're facing right now, that we can't resolve this right-hand side, yeah? All right, so here we go. I'm going to do it. Go back to the line that everyone was happy with. 2x equals e to the y minus e to the negative y. All right, what I'm going to do here is just rewrite this as this because it is that, right? That's what e to the negative y means. I can drop it down. And now what I'm going to do is I'm going to clear the fractions. And I know I saw a few students do this, clear the fractions. So I'm going to multiply both sides of the equation by e to the y. So I'm going to multiply the left side by e to the y and the right side by e to the y. Is that legal? Is that a legal move? Can I do that? Sure. All right, so I multiply this side by e to the y, multiply this side by e to the y. That should clear my fractions. On the left-hand side, I'm going to get e to the y times 2x, right? And over here, I'm going to get what? What's that? E to the 2y minus 1. I know some students, actually, you got the, right? You were there, but without this, right? Okay, so now we're here, right? We're here. So now you might be thinking, okay, I can bring in the log now. You can't, okay? Because if you do a log here, yes, you can do this and split it up into two, but if you do the log here, you see you still have subtraction? So you will not be able to resolve that. So this still, we cannot bring in log yet. You got me? You with me? All right, here's the part that I've had classes get to that step. This is the step I've never seen anyone do. Let me see, I'm going to move everything to the right-hand side. I'm going to write it this way. So what I've done is I moved this thing over to the right-hand side, and I put the 2x in front of this, and I made it subtraction, and then this should be equal to what? Because I moved everything over there, it should be equal to 0, right? So I'm going to say equal 0. You all good? No questions? Are you shaking your head? Do you see?
Yeah.
What do you see?
You gotta factor it out.
How do you factor it?
I don't remember.
You're going to use the quadratic formula. Exactly. So look, if you go back and you think about what the quadratic formula is, right? The quadratic formula says this. If you have a quadratic, right, then we have a formula to solve this. It's your solutions are x equals negative b plus or minus square root b squared minus 4ac all over 2a, right? That's our generic formula for a quadratic. But see, when we solve quadratics back in college algebra, A, B, and C, right, are usually what? Numbers, right? They're numbers. And our x is our variable. Here, our variable, we have to see this. E to the 2y is the same as e to the y squared. That's what this is. Minus 2x times e to the y minus 1 equals 0. We have to see here that the e to the y is our x in the quadratic formula, and the coefficients are the a, b, and c. So for us, a is what? 1. B is negative 2x. It's usually not a variable, right? In the quadratic formula, our b is never really a variable, but see, you can still apply the formula. And then our c here is what? Negative 1.
So are we doing a U substitution?
It's like a u substitution, exactly. And that's exactly what it is. It's a u substitution. Yeah, it's a u substitution at this step. I'm going to skip the u substitution. I'm just going to say, okay, we would do something like that. So let's go back over the quadratic formula. Here it says x will be equal to this, right? For us, what's x? E to the y. So for us, it's going to be e to the y equals, okay, negative b. What's negative b for us? The opposite of negative 2x, which is 2x, plus or minus the square root of, what's b squared for us? 4x squared. Minus, okay, 4 times a times c. So what's 4 times 1 times negative 1? Negative 4? So what's this going to turn into? Plus? Plus 4? Right? That's plus 4. Do y'all see what I'm doing? In the formula, it's the opposite of b, and over here, remember b, it's negative 2x, so the opposite of that's positive. All of this over 2 times what? 1, right? Which is just 2. Now, we have e to the y by itself, right? With no y's over here. I can now bring the log in, can't I? Because if I bring the log in now, it'll kill that off and just give me the y. I've got to do it on both sides though, right? So I'm not going to do that step yet. I'm going to do one more step first, just because I know where I'm trying to get. I recognize here that these both have a 4, right? So I can factor a 4 out of both of those, and then bring it out of the root as a 2. So I'm going to put a 2 in front of this and get rid of those 4s. So e to the y equals 2x plus or minus, there's a 2 now in front of that root. Then I have x squared plus 1 because I factored out the 4 all over 2. And the reason I did that is because now I can just reduce this all out, right? And now I have e to the y equals 2x plus or minus, not 2x, sorry. I canceled that 2 out, reduced it. X plus or minus the square root of x squared plus 1, right? And finally, the natural log. Now I'm going to bring natural log in. Natural log of e to the y equals the natural log of all of this. And then when you do this, right, the natural log and e are inverse functions. It kills everything off. You get y equals, and then natural log of x plus or minus the square root of x squared plus 1. I've solved for y, haven't I? Right? I've solved for y. So this is the inverse function. Yes?
On the sheet, it just says plus.
It just says plus, doesn't it? Okay, so that was going to be my next question because I was going to show you the formula. I was going to say, wait a minute, hold on. Our formula is wrong. Is it? We need to see why we're not, wrong class. So there's the actual formula out of the formula sheet right there. Sine hyperbolic inverse of x is natural log of x plus the square root of x squared plus 1. We have plus or minus. So let's see if we can deduce why it's the plus and not the minus. And this is a subtle thing, but it's pretty big. Can somebody tell me the relationship between this quantity and this quantity, no matter what x you ever plug in? Go ahead.
The root is always bigger.
This side's always bigger than this. This is always bigger than this. Why? Well, take the 1 away for a second. What would this be? That would just be x basically, right? Absolute value of x. But that, if I take the 1 away, then these are pretty much equal in size, right? But if I add a 1, now this is bigger than this, for sure, yes? And since if this was bigger than this, then this would be a negative number, right? And you can't take a log of a negative number. So domain-wise, we cannot include the minus, or else we have a problem with the log. So that's why it's a plus. All right. Interesting, right? To me, that's always been an interesting problem because it's a use of the quadratic formula in a way that you don't normally use a quadratic formula, and it reminds you of some of the properties of logs and that you can't abuse the properties and start doing things that aren't allowed, right? Okay, I would never give you a problem like this on a test, just as an FYI. This is more just kind of like show you like something that you perhaps had never seen. And we're going to proceed. As you might suspect, every hyperbolic trig function has an inverse function. And we could deduce them the same sort of way. The next one is cosine hyperbolic inverse. And there is its inverse. There is the definition of it. And look, by the looks of it, doesn't it seem like we would do almost the exact same thing? Right? It's probably almost the same exact setup for this. And we're going to wind up with a minus under there instead of a plus. Okay. And then the rest, tangent and hyperbolic inverse. And I put here in the notes that the book, most textbooks only look at the first 3 inverse hyperbolic functions. And that's all we're going to look at. Let me see what I have here. So my first example here for this is to show what we just did. So we just did that example. See what my next example is. All right. Now, bless you. Now derivatives. We're ready to start talking about derivatives. So I want us to show right now, how are we doing on time? I want us to show that the derivative of cosine hyperbolic inverse is equal to that. So let's take cosine hyperbolic inverse of x. Let's take its derivative, and let's show that it turns out to be 1 over the square root of x squared minus 1. Now I'm doing derivatives, all right? Now I'm doing derivatives. To show that, what I would have to do is I would first have to scroll up here, and I'd have to see what is the definition of cosine hyperbolic inverse, right? The definition of cosine hyperbolic inverse is that it's natural log, right, of x plus the square root of x squared minus 1, right? That is the definition of what this is. Right? We didn't derive that formula. We derived the one above it. But if we derive the next one, that's what we would get. What is its derivative? Is what we're being asked. Right? What's derivative? So can you take a derivative of a log? I mean, this is all Cal 1 stuff now, right? How do you take derivative of a log? 1 over whatever was on the inside. Chain rule times now the derivative of what was on the inside. Right? Derivative of log of something is 1 over that something times the derivative of what's in here. And when I take derivative of what's in here, it's addition, so I can do them separately. So derivative of x, 1 plus now the derivative of this. And derivative of that, depending on how you learned it, I teach my calculus students, what do I teach y'all about square roots? What's the derivative of square root of something? 1 over 2 square roots of that something. I know some of you are you're going to do the 1/2, that to the negative 1/2. That's fine. But when I write it, I'm going to write 1 over 2 square roots of whatever was here. Am I done? No, I still need to take derivative of what's inside here, this right here, which is 2x. So times 2x. Does all this need to be in parentheses? Absolutely, right? Because we're multiplying this times that. I'm going to clean this up because I'm trying to show, right? We're trying to show that our answer should be 1 over the square root of x squared minus 1. Wow, that doesn't look like that's going to turn into that, does it? Just by the look of it right now, it doesn't look like it's going to turn into that. But we're going to do some algebra here. So boom, boom, that's gone. So we have 1 over x square root of x squared plus 1, minus 1, sorry, times over here we have 1 plus, there's an x here I'm going to slide on top, x over square root of x squared minus 1. And there's so many different ways to do this at this point. Y'all with me though? Yes? Oh, you know what I forgot to do? I forgot to pass around the attendance. Almost forgot. I'll be pretty good with this for about a day or two, and then I'll forget. We have a new president of the college. Did you all know that? We have a new president. Really excited. I've been here since the first president was here. We've gone through, this is our third now. And she's really bringing a real good energy that we had with our first president. And so I'm really excited about it. And one of the things that she's asking us to do is to all wear name tags. And our name tags have our name, and then it just says, like, it's not like, if you're like if you have a PhD or something, it won't say doctor, it won't, you know, everyone just has a name. And then it just says like Northwest Vista College. So that way we're not like, look at me, you know? And we're supposed to wear them so that students, when they see us, they can be like, hey, you know, I have a question or something like that. So I was like, yeah, you know, I'm okay with that. I forgot I already lost mine. I mean, it's one of those magnetic ones, you know? I don't know where I lost it. It's like gone, you know? So anyway, I don't know why I'm telling you all that story, but I feel bad because I'm walking around, I'm like, I'm already that guy, you know? Where's your name tag? Oh, I don't know, somewhere. All right, I'm going to do this now. How are we doing? We're almost done? No. Okay, I have time. All right, so all sorts of different ways to do this. I just feel like doing it this way. I'm going to move all of this up on top of this. I think the reason I was thinking of that story is because I'm trying my best here to take attendance like I'm supposed to, but you know, I'm trying with my name tag and, you know, do my best. All right, we could do that, right? All right, if it were me trying to simplify this more, which it is, me trying to simplify this more up here, I would try and clear the fractions. I'd probably just multiply, I'd either like put these two together, or I just multiply the top and bottom by this root, which is, I think, the route I'm going to go. I'm just going to take root x minus 2 on top, root x minus 2 on bottom, like, or x squared minus, what am I saying? Root x squared minus 1 on top and bottom. I'm multiplying it. And then that means I have to distribute on both of them. So I have to go here to here, here to here, here to here, here to here. Hoping this is going to work out. When I go from here to here, I get root x squared minus 1. And look, you should all realize that there's multiple ways you could do this, right? When it comes to algebra, right, there's so many different paths that you could go. As long as you don't break any rules, we should all get to the same place. And you might say, hey, your way sucks. That's fine. As long as you can get there. I'm going here to here. When I go here to here, my roots cancel. I just get x. Hey, could I have just squared the top and bottom? No, you can't do that. You can't just square the top and bottom of an expression. That's not allowed. Let me see. Here to here, I get the x. It's going to be in front of this root. And then when I go here to here, the roots go away, so I get plus x squared minus 1. Oh, my goodness. What do y'all think? Does that get any better? Is that? No. So what algebra can I do at this point? So you mean try and factor it? You could? Does anyone see anything algebraically to go from here? Are you thinking, wait, I'm not sure I understand. Are you thinking like a limit? I think you might be thinking limit. We know we're supposed to get there, right? Right? That's what we're supposed to get to?
Could you factor an x in the numerator?
Could you factor out an x from the numerator?
No, the denominator.
Oh, the denominator.
So just leave it as x parentheses square root plus x minus 1 over x.
You'd have to do a minus 1 over x there, right? So look, do you all agree this looks not like that and that it seems a little bit like this is ugly? So if I were you, what I would do at this point is I would double check to make sure I've done everything correctly, right? Because this looks a little bit off, right? So let's go back. Is this the correct definition of cosine hyperbolic inverse? Yes. When we took derivative, we were supposed to do 1 over this, right? Got it? Times derivative of what's inside here. Derivative of this is 1 plus derivative of that's chain rule. 1 over 2 root blah, blah, blah. Derivative of what's inside, 2x. Cancel the 2's, bring the x on top, plus 1. Right? Here. And then I move this on top. I did that correctly, didn't miss a sign. And now multiplying through. So this is, I think that's a natural thing for people to do. Just double check, right? Make sure there's not something off in any of the previous work, because you would hate to spend 30 more minutes on this trying to simplify it and realize, oh, I did a plus instead of a minus, right? All right, any suggestions? I chose to do this, right, and come through. Any suggestions as to maybe another approach?
If you had made the 1 into root or square root of x squared minus 1.
So like get a common denominator? Is that what you're saying?
Yeah.
And then combine them? You think maybe that might have gotten us something else? That's something else I could have done, right? I like that idea. Are there any other ideas? Do we want to keep working with this? Does anyone see anything we can do here?
I can't remember what it's called, but I want to multiply by like square root of x squared minus 1 and then minus 2.
Conjugate.
Yeah.
So you're thinking, okay, maybe a conjugate. I like the idea of maybe a conjugate, except for the fact that there are 3 terms down here. And that's a little bit kind of like, I don't really like the idea that there's 3 terms, right?
Try to separate the bottom like a quadratic equation.
You could try and separate like a quadratic, like a factoring. I think someone had mentioned that before. How would we factor that though? This is more of like how would you factor that? Quadratic. So that would help you get factors, but we got to also be careful whenever you use a quadratic formula to factor something. It's a little dangerous because you can be off by a scalar multiple when you do that. So I thought I heard yes.
Can you, for the denominator, can you turn the square root into a power and then distribute the x in?
Square root into a power and distribute. I'm not sure. You mean turn what into a power?
Square root of x squared plus minus 1. Turn that, put that to the power of 1/2.
Mm-hmm.
And then the x in the front, can that be distributed into that?
Can't do that. Yeah, because there's subtraction, you can't apply the power to each one separately. Only if it was multiplication.
We're trying to show the derivative, right?
We're trying to show that the derivative of that,
Should we do L'Hopital?
well, it's not a limit, right? It's not a limit. All right, so I have 2 paths. One where I get a common denominator on top, and one where I keep trying to force my way through here. Let's make a vote as a class which way you want to go. Come back to this, forget that, do a common denominator here and see what happens, or force our way through this and hope. What do y'all want to do? Common denominator? Okay, force our way through. What does that look like to y'all? Force our way through? Okay, so did I mention persistence on our first day? Did I mention persistence in this class? So one of the biggest attributes that a student who does well in Cal 2 is persistence, right? You cannot face something like this and just be like, I'm not good enough at math. I can't do this, right? You've got to just keep trying until you get to it, right? There's going to be a lot of times when you're doing your homework that you're going to do problems wrong, and you're going to have to start over, and you have to have the actual like mental fortitude, endurance, right? To continue to press on even as you struggle. This class, more than any math class you probably have taken, is going to be, you're going to learn by failing. You're going to learn by getting things wrong. That's how you're going to learn. And hopefully by the time you get to the test, you can get 90% or higher of it right, you know? So this is a good example of a problem where persistence is going to hopefully pay off for us. So I'm going to stick with this, all right? I'm going to stick with that bottom one. How are we doing on time? Oof. I always think I'm going to just blow through this section, and I just get bogged down in here. All right. You have two terms in the numerator, right? Two terms in the numerator and three terms in the denominator. Could you split this into multiple fractions if you wanted to? Could you? You could? I'm looking for someone to just give me a way that they want to go. Yes?
I have a question.
Yes.
The top part, if you multiplied by the conjugate of it, wouldn't it give you something really close to the bottom?
You're saying here?
Yeah, like the top part, say kind of you yanked the top part out and turned it into a 1, and you did the same thing to the bottom, wouldn't it give you something really close to what the top is right now? Like, if you multiply the top by the conjugate, wouldn't it give you something very close to what the bottom is right now?
I don't know. Should we try? So I'm just wanting you to tell me what someone give me the next step.
I want to set it equal to 0.
Well, but we're not trying to solve an equation. We're trying to just manipulate an expression to make it look like that, right? Would you like the conjugate? You want the conjugate. Come on, just admit it.
I want to see how it's going to
Okay, let's do it. Let's do the conjugate, all right? Look, this is the whole idea. Is like you've got to try something, right? You've got to try something. As long as you've convinced yourself that you made no mistakes. Let's do this also. Let's check our formula sheets. Is that right according to the formula sheet? Is the derivative of the inverse hyperbolic according to that? Yes? Yes. Okay, so there's no typos. I remember I worked on a problem for 3 weeks in grad school that I couldn't figure out, and it was a typo by the professor.
Minus x squared.
Pardon?
1 minus x squared.
Is it 1 minus x squared on there?
Because the derivative of the cosine is sine.
No, hyperbolic.
Yeah, sine hyperbolic. Oh, wait.
One down, right there.
Oh, okay.
Yeah. So the formula is right. Okay, I'm coming in with the conjugate. Here we go. We're doing it. The conjugate of this is this. Right? And I'm going to multiply them top and bottom. Now, what we know is that on the top, things should get nice, right? The top, things should be really, really nice. The bottom looks like a disaster right now, doesn't it? But I'm not going to worry about that. I'm just going to do the top. So when I do the top, right, I have to like FOIL this out. Here to here, what do I get? X squared minus 1. And then when the middle terms will cancel out, right? So all I have to worry about is this, which is? Minus x squared. Over. Okay, let's not worry about the over right now. What's the numerator? Negative 1. Well, it's 1 here. At least we've got that, right? So the top is negative 1. Okay. The bottom. Well, we got to do it. This is 3 terms. This is 2 terms. That means we have to do 6 multiplications. Right? All right. You shouldn't be intimidated by 6 multiplications. Here to here. What do we get when we do that? Well, the x stays, right? And the two roots go away and become just x squared minus 1? Okay, so I should have an x. Let me give myself some room here. I have x, and then the two roots went away. I have x squared minus 1. That's what this first multiplication is. Do you all agree with that? Okay, now I'm going to go here to here. What do I get there? You get a minus, and it's x squared in front of that root. All right. Not happy, but let's keep going. All right, this one, here to here. What do you get? X squared in front of that root and positive. That's encouraging. Because that cancels with the previous one, doesn't it? Okay, hey, maybe this is going to work. We need a negative. What do we need the bottom to be? What do we need the bottom to turn out to be? This right here, but negative in front, right? Because our top, remember our top's -1, isn't it? Okay, let's keep going. So I've done this to this. I still need what? This to here, which would give me negative x cubed, all right? And now the last multiplication, here to here, negative root x squared minus 1. And the final one is plus x.
You said the top is supposed to be a negative 1.
It is -1 because these two go away and you just get -1 up top.
Oh, I thought you meant like
No, I'm saying because we have -1 here, that we know that whatever happens down here, if we're going to get that answer, needs to be that root with a negative in front. All right, so yeah, that's the multiplication. Let's, that just felt good, being able to do that, right? But I wish there was more. Is there more? Ah, there is more. Look, what is this? This is x cubed minus x, isn't it? Distribute. Wait a minute, don't I have that over there? Gone. Gone. Holy shit. That's exactly what I wanted, right? -1 on top. What's on the bottom? Negative root x squared minus 1. The two negatives become positive. You've got it, right? You should have just taken the leap. You were there. You were at the edge.
I didn't want
Take the leap.
to say we got to do the hard shit or it's just not going well.
No, I mean, that was good. You have to, I mean, so who else mentioned conjugate? Someone else mentioned, right, Chris? So conjugate, right? Now, am I saying that's the only way? Am I saying that's the cleanest way to do it? No. It might have, Jackson, might have worked better if did you do it the other way?
so easy.
So easy, right? This is something we face a lot in all math classes, especially when the algebra starts getting tricky, is you start, you just have to like choose a path at some point. And sometimes that path works out to be good. Sometimes the other path the other person next to you tried was better. But then there's a person who just doesn't ever choose a path or breaks